Okay, today I'm going to talk about the review for section 3.4, 3.5, 3.7. So here, the first one, the definition. The limit of f of x as x approaches infinity equal to L. So what does it mean? The if f of x can be close to L by taking x sufficiently large. The limit of f of x as x value approaches negative infinity equal to L if f of x can be close to L by taking x sufficiently large negative. Y equals L is a horizontal asymptote of y equals f of x. The if either limit of f of x as x value approaches infinity equal to L or limit of f of x as x value approaches negative infinity equal to L. This is some the definition of horizontal asymptote. So in this case, x value approaches positive infinity. So what happens? F of x approaches to y equals L. So satisfies this condition. YZL is horizontal asymptote. The second case, x value approaches negative infinity. So this function f of x approaches to the y equals L. So we have this condition, y equals L is horizontal asymptote. This is the exact definition. So theorem, the R is greater than 0 is a rational number. Then limit of R, 1 of x to the R as x value approaches infinity equal to 0. The R is greater than 0 is a rational number such that XR is defined by all x values. The limit of x value approaches minus infinity, 1 of x to R is going to 0. So what does it mean? So like this. So one example is limit x value approaches infinity, 1 over x. So in this case is 0 because power is 1. We have this case. So here limit x value approaches minus infinity, the 1 over x square. This is also approach to 0. We have second case. This R is greater than 0. The remarks. Nth root of x to n is absolute value of x for any even integer n. The nth root of x to n equals exactly x for any odd integer n. Just an example. So was like a square root of x squared? This is exactly same to absolute value of x because the index is 2, like even integer. So we have two possible answers. If x is greater than or equal to 0, x. If x is less than 0, minus x. The square root of x to the 4, so same. Index is 2. So even we have absolute value. So we have change like this, absolute value of x squared. So x squared is always a positive number, exactly x squared. X is like positive number, one negative number, it doesn't matter. The absolute value of x squared is x squared. The square root of x to the 6 is similar, square root of x cubed squared. So absolute value of x cubed, we have two possible answers. If x is greater than or equal to 0, x cubed. If x is less than 0, minus x cubed. Cube root of x cubed is just x, because 3 is odd integer, exactly x. So we have this result. So how can we evaluate the following limit values? key. Eliminate lower power terms from the top and the bottom one. This is like idea. The first one, limit x value approach infinity, 7x cubed negative 4x minus 2 over 6x cubed plus 2x squared plus 5. What's like a key? You have to eliminate lower terms in the top and the bottom. So we have like this one. The next, the cross out x cubed, answer is 7 over 6. Limit of 7x cubed minus 4x minus 2 over 6x cubed plus 2x squared plus 5. X value approaches minus infinity. So same idea. You have to ignore lower terms. So like this, we have this one. Next, cross out x cubed, 7 over 6. So we have one note. F of x equals 7x cubed minus 4x minus 2 over 6x cubed plus 2x squared plus 5 has the horizontal asymptote. What's the horizontal asymptote? Y equals this limit value 7 over 6. This is exactly the horizontal asymptote. The limit of square root of x squared plus x plus 1 minus 4x over square root of 4x squared plus 2x plus 1 minus x as x value approaches positive infinity. How can you solve? Same idea. You have to eliminate lower terms. So we have the like this. Next, you can change it. This is like the even index. This one is same to absolute value of x. This is the same to absolute value of 2x. Change it like this. So what's it like x values? X value approaches positive infinity. So absolute value of x is just x. This is also x. So we have it and simplify. X minus 4x is negative 3x. The 2x minus x is x. Next, the cross out x. Answer is negative 3. This limit the square root of x squared plus x plus 1 minus 4x over the square root of 4x squared plus 2x plus 1 minus x. How can you solve? Same idea. You have to ignore lower terms. This one. So we have this one, the same. So this one is absolute value of x. So this one is the 2 times absolute value of x, the same. The next, x value approaches minus infinity. What does it mean? X is negative number. So absolute value of x is minus x. Absolute value of x is negative x. So we have negative x minus 4x over negative 2x minus x. This is negative 5x. This one is negative 3x. So we have the like this. X is crossed out. Final answer is negative 5 minus 3. The minus 1 is gone. 5/3. So note, f of x is this function, the square root of x squared plus x plus 1 minus 4x over the square root of 4x squared plus 2x plus 1 minus x has 2 horizontal asymptote. What's that? Here, x value approaching infinity, limit value is negative 3. X value approaches minus infinity, the 5/3. We have 2 horizontal asymptote, y equals negative 3 and y equals 5/3. So we have the next one, the cube root things. How can you solve? Same idea. You have to ignore lower terms. The same. This one. So we have it. So this is like odd power. So what does it mean? This is odd index. We can change to the only x. This is the same to 2x. Don't take absolute value because we have odd index. So like this, simplify. This one is negative 3x. This one is just x. X is crossed out. So we have negative 3. X value approaching minus infinity, the same method. You have to ignore x1, 2x1, lower terms, but like this, the same. X value approaching minus infinity, it doesn't matter. So this is same to the absolute value of x, no, just x. This is the same to only 2x. So answer is x minus 4x over 2x minus 4. So simplify. So this one is negative 3x. The bottom one is only x. So we have it. So same. You have to cross out x. We have negative 3. So why is it like a horizontal asymptote? The x value approaches minus infinity and the positive infinity. So we have same number minus 3. The horizontal asymptote is y equals negative 3. So like this. Next tip. How to find the vertical and the horizontal asymptotes of f of x equals nx over dx. The nx is like a polynomial a sub to n x to the n plus a sub to n minus 1 x to the n minus 1 plus and so on plus a1x plus a0. The denominator is also polynomial b sub to mx to the n plus b sub to m minus 1 x to the m minus 1 plus and so on b1x plus b0. How to find a vertical asymptote? This is the idea. Step 1. Simplify nx over dx by crossing out the common factors of nx and dx. Step 2. Solve the denominator equal to 0 from step 1 for x. So how to find the horizontal asymptote of f of x? You can compare powers. So here, n is like top on power. The m is like bottom power. The top on power is less than bottom on. The horizontal asymptote is y equal to 0. N equal to m. So here, the power n is exactly same to bottom power m. Y equals exactly coefficient a n over p sub 2m. N is greater than m, so we don't have a horizontal asymptote. I want to give the one example. The f of x equals the 5 over x plus 3. What is vertical asymptote? So could you write your answer on the chatting board, please? What is the vertical asymptote of this function? Do you know what is the vertical asymptote? I want to use these steps. So what do you think? Could you write your answer on the chatting board, please? So what do you think? What is like a vertical asymptote? The vertical asymptote is, here. So do we have a common factor or not? In this case, we don't have common factors on the top one and bottom one. You have to skip. You have to skip step 1, going to step 2 directly. What is like step 2? Denominator equal to 0. Just x plus 3 equal to 0. So x equals negative 3. You're right. Yes, that's it. So we don't have a common factor. You have to skip step 1. So what is horizontal asymptote? Yeah, good. What's a horizontal asymptote? You can compare the top on power and the bottom power, we can use this rule. So what's that? You're right. So because what's the top on power? So we don't have any power, only 5. What does it mean? Top on power is like 0. Bottom power is x to the 1. M is 1. We have y equal to 0. That's it. You're right. Yes. So like this. One more problem. F of x equals the 3x plus 1 over the x minus 2. So similar. What is vertical asymptote? What's a vertical asymptote? Yeah, x equals 2. It's good. Because the same. 3x plus 1, x minus 2, we don't have a common factor. You have to skip step 1, going to step 2. Denominator equal to 0. Denominator is x minus 2 equal to 0. X equals 2. The horizontal asymptote. So what's it like a horizontal asymptote? So we can use this rule. What is a horizontal asymptote? So 0? No. Was it like a top on power? Top on power is power 1. This one is exactly root of n. 1. Bottom power is also 1. We have same. We have same power. What is the answer? Y equals an over pm here. Coefficient over coefficient. The coefficient of first one is 3. The coefficient of bottom one is just 1. Exactly y equals 3 over 1. So we have 3. Yes, only power in the variable x. You're right. Yes, only think about power of x. Yep. This is idea for finding horizontal asymptote. Now I want to give the more examples here. Find the horizontal vertical asymptote of f of x. What happens? So here, the highest power of the numerator is 2. The highest power of the denominator is 2. We have same power. What is horizontal asymptote? Do you know what's a horizontal asymptote? So do you remember horizontal asymptote? Here, we have same power, the coefficient of a coefficient. So what is the answer? What is the answer? Horizontal asymptote? Yes, here, you're right. So 4 over 1, yes. 4, y equals 4 is horizontal asymptote. So like this. The horizontal asymptote is y equals 4. How can you find the vertical asymptote? Step 1. You have to factor numerator, denominator. So here, top on factor of 4. So 4 times x squared plus x minus 2 over bottom on x plus 3 times x minus 1. You can factor numerator more. Do you know what is the factor form? X squared plus x minus 2. Do you know what is the factor form on the numerator? What's it like a factor form? How can you factor? So like this. We have this is x, this is x. What's it like numbers? So do you know factor form? The factor form is, you're right. The one part is minus 1. What's the other one? The other one is plus 2. You can factor like this. So what happens? Yeah, you're right. x minus 1 is common factor, just to cross out common factor. We have 4 times x plus 2 over x plus 3. So next step, the solve denominator equal to 0. X plus 3 equal to 0, subtract 3 from both sides, x equals negative 3. So the vertical asymptote is x equals negative 3. This is the whole idea for solving this kind of problems. The guideline for sketching a curve. So first, find domain. Second one, find intercepts. You need to find y-intercept and the x-intercept. The third one, check symmetry. The next one, you can find asymptotes. You can find vertical asymptotes, horizontal asymptote. Sometimes you need to find the slant asymptote. The next one, you can check the function f is increasing or decreasing. Next one, find local maximum and the local minimum. So G, you can check concavity, find point of inflection. The last one, sketch the curve. How can I sketch the curve? We can follow these steps. Using the information in item A through G, draw the graph, domain, intercept, symmetry, asymptote, increasing, decreasing, local maximum, local minimum, concavity, point of inflection. This is like idea. Sketch the asymptote as a dashed line is first. Next, plot the intercepts, maximum, minimum points, and inflection points. Then make the curve path through these points, rising and falling according to E. What's it like E? E is the increasing or decreasing. And you can check concavity according to G, approaching the asymptotes. This is a whole idea for sketching the graph. So we think about symmetry. What's it like the definition of symmetry? The function f is an even function. The f of minus x equals f of x for all x in the domain D. The f is like odd function if f of minus x equals minus f of x for all x in the domain D. The function f is periodic function. The f of x plus p equal to f of x for all x in the domain D, where p is positive and the smallest such number p is called the period. So this is like even function. Does it make sense? You can choose minus x here, choose x here. What's that? Function value is exactly same. So function value is, you can plug minus x, f of minus x is here. This is also plug x into f, same to the f of x. We have even function. What happens? Even function is symmetric about y-axis. Here, even function. The curve is symmetric about y-axis. This is like odd function. You choose 2 points. This value is minus x. This value is like x. You can find function value. This one is f of x. So you can find function value here. This is f of minus x. What's the like relation? The f of minus x is exactly same to take negative sign of positive value. You can take minus f of x. What does it mean? Function f of x going down like this. We have this result. This is exactly other function. Other function is always symmetric about the origin, right? Symmetric about the origin. The next one. This is periodic function because this part is, this portion is repeated, and repeated. So we have periodic function. The example of even function, y equals x squared, y equals x to the 4. y equals absolute value of x, y equals cosine of x. The example of other function, y equals x, y equals x cubed, y equals x to the 5, y equals sine, and tangent, all other functions. What's the example of periodic function? We have three basic functions, sine, cosine, tangent. What's like a period of sine and cosine? Always 2 pi. The period of tangent function is like pi. This is the whole idea. Next example. F of x equals sine x plus x over 2x to the 6 plus x squared plus 1 is even, odd, or neither. How can you know that? You calculate f of x. The f of minus x, you calculate this one. You plug minus x into x. Sine of minus x plus minus x over 2 times minus x to the power 6 plus minus x to the power square, power 2 plus 1. What happens to sine function here? The sine function is odd function. What does it mean? Sine of minus x is exactly same to negative sine of x. This meaning. So we have minus sine of x. So plus 1 times minus x is negative x over, next, minus x to the power 6. 6 like even power, exactly x to the 6. Same. Minus x to the power 2. 2 is even power plus x squared plus 1. Next, the factor out minus 1. So we have negative sine of x plus x over the 2x to the 6 plus x squared plus 1. So what's that? You can take out minus 1 in the middle, the sine of x plus x over the 2x to the 6 plus x squared plus 1. What's that? This part is exactly same to f of x. You can replace. We have minus f of x. The f minus x is exactly same to minus f of x. This is what? Odd function. Odd function is symmetric about the origin. About the origin. This is whole idea for solving this problem, like this. So far so good. Yeah, you can only check sometimes true false problem. The function is even, this function is true or false. Or you can check the function is even, odd, neither. We don't check the periodic. Don't worry about the periodic. Just even, odd, or neither. You can check these kind of things. Yeah. So I want to give some of the more examples of this kind of things. Some of the the next part. So yeah, it's good. This is the answer your question. How to find a slant asymptote? So power n, this one, the numerator is always not equal to bottom one plus 1. So what does it mean? No slant asymptote. But top one power is only one more than bottom one. So here top one power is one more than bottom one. So like this. Yes, we have slant asymptote. Step 1. How can you find the slant asymptote? Use long division. Step 2. Y equals quotient. From the long division is the slant asymptote. This is an example. Would you like a top one power? Top one power is 2. Is right? Top one power is 2. Bottom power is 1. Top one power 2 is exactly 1 more than bottom power. 2 is same to 1 plus 1. Is right? Like this. Yes, we have slant asymptote. How can you find? We use long division. the numerator divided by denominator, like this. So what kind of things do you need? only 답은 we need only 2x. The 2x times 2x is 4x squared. The minus 1 times 2x is negative 2x. Next, subtract. 4x squared is gone. The negative 3x minus negative 2x is negative 3x plus 2x. We have minus x plus 1 is down. So like this. How can you make minus x from the 2x? You can multiply by minus 1/2. Minus 1/2 times 2x is negative x. Minus 1 times minus 1/2 is plus 1/2. Subtract again. X is cancelled. 1 minus 1/2 is just 1/2. So was it like a slant asymptote? The slant asymptote is y equals quotient. Exactly. Slant asymptote is y equals quotient. 2x minus 1/2. So that's it. This is the whole idea for solving this problem. So like this. Okay. Use the guideline to sketch the curve y equals x squared over x squared plus 3. So how can you find the domain? So in this case, domain is, what's the domain? What do you think? What's the domain? How can you find the domain? How can you find the domain? Yes, all real numbers, because in this case, domain is the denominator is not equal to 0. This is one important thing. The denominator is not equal to 0. The denominator is not equal to negative 3. So what happens? The x squared is always positive. The minus 3 is like a negative number. So what does it mean? All real numbers. All real numbers, exactly domain. How can you find the y-intercept? The y-intercept is f of 0. We can plug 0 into x here. So we have 0 squared plus 0 squared plus 3 is 0. 0 is y-intercept. How can you find x-intercept? X-intercept is f of x equal to 0. So we have, so exactly this one. What's f of x equal to 0? F of x equal to 0 is, this one is f of x. This function is f of x. So we have x squared over x squared plus 3 equal to 0. Exactly, numerator equal to 0. We have x squared equal to 0. What is x? X is 0. So x equal to 0 is x-intercept. This is idea. How can you check symmetry? You calculate f of minus x. You plug minus x into x here. Minus x squared over minus x squared plus 3. Exactly, x squared over x squared plus 3, same to f of x. This function is even function. The even function is always symmetric about y-axis. Like this. The next one, you can check asymptote. How can you find asymptote? Here, the first one. The top on power 2, bottom power 2. We have same power. What does it mean? We have horizontal asymptote. What's a horizontal asymptote? What's a horizontal asymptote? Do you have an idea? The horizontal asymptote is, remember, we have here same power, 1 over 1, not 2 over 2. Here, coefficient of x squared is 1. coefficient x greater like 1, exactly here, 1 over 1. Yeah, 1 over 1. Yep. Y equals 1. This is a horizontal asymptote. The denominator equal to 0. This is a vertical asymptote. X squared plus 3 equal to 0. We don't have x value. No vertical asymptotes, right? So we don't have a real number. So we don't have vertical asymptotes. The next, the find intervals of increase and decrease local maximum. So f prime of x. F prime of x is x squared over x squared plus 3 prime. So let me see. I don't calculate. The calculation is not difficult. Just use quotient rule. So like this. So like this. Simplify. We have 6x over x squared plus 3 squared. This is like f prime of x. The next, I want to find critical number. F prime of x equal to 0 or f prime of x does not exist. So f prime of x equal to 0 exactly numerator equal to 0. F prime of x does not, so we have 6x equal to 0. The first one exactly divided by 6. So we have x equal to 0. Second one, the f prime of x does not exist exactly denominator equal to 0. So this is typo. Sorry about that. This is what? 3. The 3. So we don't have it. The same thing. This is like a 3. But we don't have a real number x. We don't have it. So next, you can sketch the graph here. You have to plot. So what's that? Only one number, 0. 0. You can check. F prime of x. What happens f prime of x? You can choose test number. I can choose -1. You plug -1 into x here. You can plug -1. The 6 times -1 is negative. -1 squared plus 3 is always positive. So here, negative. You can choose another test number on the right hand side, plug 1. Positive 1. What happens? 6 times 1 is positive. 1 squared plus 3 is positive. We have positive. What's it like f of x? F of x is decreasing and increasing. So we have this rule like this. F is decreasing on negative infinity to 0, increasing on 0 to infinity. Do we have a local minimum? Do you have a local minimum? Do you have a local minimum? Do you have a local minimum? Yes, we have, yep, thank you. The graph is decreasing and increasing. Yes, we have a local minimum at 0. You can calculate f of 0. You plug 0 into here. Here, the 0 square over 0 square plus 3, exactly 0. This is local minimum because 0 is in the domain. What's the domain? Remember domain? The domain is all real numbers. This is the reason. Next, concavity and point of flexion. How can you find the concavity? Second derivative. Was it like the first derivative? The first derivative is the previous pages. We have 6x over x squared plus 3 squared. Was it like a second derivative? Second derivative is the derivative of the first derivative. Apply. You calculate like this. Same. I don't calculate. The calculation is up to you. You can use quotient rule, simplify. We have this answer. 18, 1 minus x, 1 plus x over x squared plus 3q. The similar, you can define x values such that The second derivative equal to 0 or does not exist. The second derivative equal to 0. So what does it mean? Just to numerator equal to 0. So we have it. So x is plus minus 1. The second derivative does not exist. Only bottom one equal to 0. So we don't have it. So next, you can draw line here. Real line. You can plot 2 points. So like this. So what's that? You can choose test point. This is like -2. You plug into second derivative. You plug -2 into x squared. X. You plug -2 into here. Into here. So 1 minus -2 is positive. 1 minus 2 is negative. The -2 squared plus 3 is always positive. We have only one negative. This is like a negative. You can choose test number 0 in the between -1 and 1. You can plug 0. You can plug 0 into x. Plug 0 into x. 1 minus 0 is positive. 1 plus 0 is also positive. 0 square plus 3 cube is positive. So we have positive. But next, you choose 2 on the right hand side. You plug 2 into x. Plug 2, 2, 2. Was it like the first one? The first one. 1 minus 2 is negative. So we have this is negative. 1 plus 2 is positive. 2 square plus 3 is positive. We have negative. Was it like f of x? F of x is first one, interval, concave down. Concave down. Here, positive, concave up. Negative, concave down. This is like a whole idea. We are going to the next one, like this. So we have a inflection point. So do we have an inflection point? Yes. How many inflection points do we have? Do we have how many? Yes, 2. Concavity changed from down to up. We have inflection point at -1. Up to down at 1, we have a second inflection point. This inflection point, yes. -1 and 1 are in the domain. The function f is continuous at -1 and 1. We have 2 inflection points. You can calculate -1. You plug -1 into x here. The -1 square over -1 square plus 3 is 1/4. The f of -1 equals, this is like a typo, sorry. The +1, you plug 1 into here again. So we have 1/4. So what's that? We have 2 inflection points, -1, 1, 4, 1, 1, 4. We have 2 inflection points. Like so, because function f is continuous at ±1. The next, you can combine all things. From the previous one, this is decreasing and increasing, concave down, concave up, concave down. We have domains of real numbers, x-intercept 0, y-intercept 0, horizontal asymptote, y equal to 1, no vertical asymptote, local minimum at 0, 0, inflection point -114, 114. So you can sketch the graph. How can you sketch the graph? Graph is like this. The first one, you can draw asymptote, only one asymptote, y equals 1. horizontal asymptote. X-intercept 0, Y-intercept 0, this point. Local maximum minimum here. We have inflection point minus 1, 1, 4. So this is minus 1, 1, 4. This is 1, 4. The 1 and 1, 4. So here. We have two inflection point. The next, you can sketch the graph passing through this point. What's that? The x is less than minus 1. What's that? Decreasing concave down. So always approach to the horizontal asymptote. Horizontal asymptote, decreasing concave down. So here, 0. Minus 1 to 0, decreasing concave. Concavely change it like this. So the 0 to 1, increasing concave. Graph is increasing concave up. Last one, increasing concave down. Just to approach it to the horizontal asymptote, like this. This is inflection point 1, 1, 4. This is inflection point minus 1, 1 over 4, like this. This is the whole idea for sketching the graph, like this. The next example, use the guideline to sketch the curve y equals x squared plus x over x minus 1. What's like a domain? So what do you think? What's the domain? Domain is, do you know domain? I don't think so. The same things. Denominator is not equal to 0. You can add 1 to the both sides. X is not equal to 1. So what does it mean? This is all real numbers except to 1. So this part and this part, we have like this. Negative infinity to 1, union 1 to infinity. So all real numbers except 1. So you can plug 1 undefined. So like this. How can you find the intercept? Same. Y-intercept is f of 0. You plug 0 into x here. So 0 square plus 8 over 0 minus 1. The 8 over minus 1 is minus 8. How can you find the x-intercept? You solve f of x equal to 0. The f of x equal to 0 is only this one equal to 0. Exactly, only numerator equal to 0. The numerator equal to 0, impossible. So we don't have x-intercept. The symmetry, you calculate f of minus x. You plug minus x into x. You plug minus x into x here. Negative x squared plus 8 over minus x minus 1. So x squared plus x over minus x minus 1. This is like f of x, is right? So what's like f of x? This is not equal to f of x. What's like minus f of x? The minus f of x is, you can take a negative x squared plus 8 over x minus 1. The minus 1 is going to denominator. We have x squared plus 8 over the minus x plus 1. Not the same, minus x minus 1. What does it mean? Not equal to minus f of x. So what does it mean? Not even, not odd, the neither. So we don't have any symmetry. It's right. So don't check periodic. Don't check periodic. So no symmetry in this problem. Asymptotes. Do we have a horizontal asymptote? So do we have the horizontal asymptote? What do you think? Do we have a horizontal asymptote? No, because the top on power is 2, bottom power is 1. Top on power is greater than bottom power. We don't have a horizontal asymptote. Only the bottom power, yeah, this is bigger, yeah. So we don't have it. No horizontal asymptote. Do we have a vertical asymptote? The vertical asymptote. Do we have a vertical asymptote? Yes, you're right. Only denominator equal to 0. X minus 1 equal to 0. Add 1 to the both sides. X is 1. So one more. The top on power is 1 more than bottom on. We have slant asymptote. We have a slant asymptote. How can you find the slant asymptote? We have to use long division here. This one divided by x minus 1. We need x. X times x is x squared. Minus 1 times x is negative x. You can subtract. Is gone. We don't have any x terms. Negative x is positive x. So 8 is down, plus 8. So x plus 8. We need only 1. X times 1 is x. Minus 1 times 1 is negative 1. Subtract again. X is cancelled. 8 minus 1 is 9. So what is the slant asymptote? Slant asymptote is exactly quotient. The y equals x plus 1. This is idea. So we have it like this. Next, interval of increase, decrease. How can you find f prime of x? F prime of x is x squared plus 8 over x minus 1 prime. The same. You can use quotient rule. We have this result. So next, you solve f prime of x equal to 0 or f prime of x does not exist. F prime of x equal to 0, so what does it mean? Only numerator equal to 0. Do we have it? You solve x equals negative 2 and 4. Second one, the f prime of x does not exist exactly. Denominator equal to 0. We have x minus 1 squared equal to 0. X is 1. We have 3 points. So I can do that. You can draw line like this. You plot the negative 2, plug 1, plug 4. We have 4 intervals. You can check f prime of x. So I can choose negative 3. Test point. You plug negative 3 into x here. Negative 3, negative 3, negative 3. What's that? Negative 3 plus 2 is negative. Negative 3 minus 4 is negative. The negative 3 minus 1 square. The square is always positive. The negative times negative is positive. I can choose the 0. You plug 0 into x. Plug 0 into x. This one. The 0 plus 2 is positive. 0 minus 4 is negative. 0 minus 1 square is positive. We have negative. I will choose 2. You plug 2 into x. You can plug 2 into the x. Plug 2, 2, and 2. 2 plus 2 is positive. 2 minus 4 is negative. 2 minus 1 square is 1 square equals positive. We have also negative. So here, I'm going to choose 5. You can plug 5 into x. 5, 5, and 5. 5 plus 2 is positive. 5 minus 4 is positive. 5 minus 1 square is positive. This is positive. So what's that? The graph f of x is, what's that? Here, increasing, decreasing, decreasing, increasing. So we have it like this. So we have it like this. So what's that? Here, increasing on 2 intervals, the here to here, increasing. So here to here, increasing. So we have it. The decreasing on 2 interval, -2 to 1, 1 to 4. So do we have a local maximum? The local maximum? Yes, local maximum. Graph is increasing, decreasing here. We have -2. We have a local minimum? Yes, 4. It's good. Local minimum at 4. Because the -2 and 4 are in the domain. This is the reason. What's the domain? The domain is like -infinity to 1, 1 to infinity. This is the reason. The -2 is in the domain. The 4 is in the domain. Yes. F -2, you plug -2 into here. X. The -2 square plus 8 over -2 minus 1. The 12 over -3 is -4. Local maximum value. F of 4. Plug 4 into X. 4 square plus 8 over 4 minus 1 is 24 over 3. 8 is a local minimum value. You can check concavity. How can you check concavity? Second derivative. Exactly the first derivative. The first derivative is here. Exactly expand x squared -2x minus 8 over x minus 1 the square and prime. It's like a second derivative. You can use quotient rule. I don't calculate. The calculation up to you, but not difficult. So we have like this. So we have it. The next thing, you can check find second derivative equal to 0. Second derivative does not exist. What's like a second derivative? I can do right here. So second derivative is, so we have 18 over x minus 1 cube. X minus 1 cube is the second derivative. So we don't have it here. So what's like the first one? Just numerator equal to 0, impossible. 18 is not equal to 0. We don't have it. Second derivative does not exist. Bottom one equal to 0. X is exactly 1. We have 1 point like this. The next is, so you can draw, this is only 1. So what's like a second derivative? The second derivative is we have 18 over x minus 1 cube. So we have it. You can choose test number 0. You plug 0 into x. What's that? 18 is positive. 0 minus 1 cube is negative 1 cube is negative. We have negative. Choose 2. You plug 2 into x. The 2 minus 1 is positive. So we have positive number. So what's the concavity? Graph of f is concave down, concave up. This is like idea. So like this. Do we have an inflection point? Do we have an inflection point? No, in this case, no. Remember, what's the domain? The domain is yes, all real numbers except 1. 1 is not in the domain. So what does it mean? We don't have an inflection point. Yeah, because 1 is not in the domain. So you can combine these two results, and domain is all real numbers except 1. No x-intercept. The y-intercept is -8. No horizontal asymptote. Vertical asymptote x equals 1. the slant asymptote y equals x plus 1, the local maximum at negative 2 and minus 4, local minimum at 4 and 8, no inflection point. So what's like a graph? The graph is like this. We can sketch the graph. So graph is this one. So like this. You can plot the vertical asymptote. X equals 1, so we have x equals 1. X equals 1, this is a vertical asymptote. We have slant asymptote, y equals x equals x plus 1. So like this. So next to you plot. We don't have x-intercept, y-intercept is minus 8. This is negative 8. Negative 8. You plug minus 2 and minus 4, local maximum. Then negative 2, this is minus 1, 2 is here. So like this. We have local minimum 4 and 8. So 4 and 8. We have it. So what's the graph? So less than negative 2, graph is increasing concave down. So graph is like this. Increasing, when you approach it to the slant asymptote, concave down. Graph is like this. Concave down. So negative 2 to 1. Decreasing concave down. We have local maximum, concave down, decreasing, approach to vertical asymptote. So like this. The next one, 1 to 4. Was it like 1 to 4 here? Decreasing concave. Graph is decreasing. Just approach to vertical asymptote, concave, so like this. The last one, 4 to infinity, increasing concave. So here, increasing concave, approach to the slant asymptote. So we have this graph, so like this. So we have it. It's good. This is the whole idea. The next, do we think about optimization problem? How can we solve optimization problem? We can follow 4 steps, these steps. Step 1, understand the problem. Step 2, draw a diagram. Step 3, introduce notation. The what's Q, the quantity that is to be maximized or minimized. A, B, C, X, Y, other unknown quantities. Step 4, express Q in terms of some of the other symbols from step 3. Step 5, express Q as a function of one variable X, let's say Q equals f of X. Write the domain of F. Step 6, find the absolute maximum or absolute minimum value of F by using closed interval method, first derivative test, or the second derivative test. This is the whole idea. So this is a problem. A farmer wants to fence in an area of 1.5 million square feet in a rectangular field and then divide it in half with a fence parallel to one of the sides of the rectangle. How can you do this so as to minimize the cost of the fence? So step 1, step 2 and 3, you can draw diagram. We have here. We have what? The rectangular field, the one more. So divide it half with the fence, like this. This is X, this is X, this is X, this is Y, this is Y. We can use some symbols. This is X, this is X, this is Y, like this. So what is it like X? The width of the rectangle, Y, the length of the rectangle. So what's it like the main problem? Main part is the minimize the cost. How can you minimize the cost? Just minimize the amount of fencing, right? So you have to minimize amount of fence. You can minimize the cost automatically. It's like idea. So step 4, you can define the equation of L. The L equals here. What's that? 3x plus 2y. We have the 3x is here, the 2y's, the 3x plus 2y. The next, you can change L equals 3x plus 2y to only function of one variable. So you need to find relation of x and y. How can you find the relation of x and y? So we can use this number. Was it like area of a rectangle field? Area is 1.5 million square feet. We can use it. So we have x times y is 1.5 times 10 to the 6, exactly 1.5 million square feet. You can divide by x, the y equals 1.5 times 10 to the 6 over x. You can plug this one into here. We need the plug. Same to like this, because so here the 2 times 1.5 is 23. The 3 times 10 to the 6. This is not the x, the times. This is x. This is x. The bottom is x. So what's it like capital F of x? Find domain. Domain is just positive. X is a positive numbers, right? The length and width is always positive. It's like domain. So next, use the first derivative test for finding absolute minimum value of L. So f prime of x is 3x plus 3 times 10 to the 6x prime, right? Here. Take this one prime. This one prime. Fine. This one prime. Do we have it? So like this. What's 3x prime? 3. What's like 3 times 10 to the 6x prime? We have 3 times 10 to the 6 times x to the minus 1 prime. Right? So we can keep constant 3 times 10 to the 6 times power rule. Minus 1 is down, x to the negative 2. So 3 times 10 to the 6 times minus 1 is negative 3 times 10 to the 6. You can change this one to the negative, the positive exponent, 1 over x squared. So like this. So we have it. So like this. The next, change it to this one. How can you change it? Here. This 3 is the same to exactly 3 over 1. You multiply top and bottom by x squared. Minus 3 times 10 to the 6 over x squared. Combine 3x squared minus 3 times 10 to the 6 over x squared. The 3 is common factor, factor of 3 over x squared. This is like idea, like this. Next, find the critical number. What's that? F prime of x equal to 0 or does not exist. So what's that? The f prime of x equal to 0 is only numerator equal to 0. We have x squared negative 10 to the power 6 equal to 0. This is x squared equals 10 to the power 6. You can take square root. This is x, so what's that? This one is 10 cubed. This one, square root is gone exactly 1000, 10 cubed. So this is like even power, we have two numbers, plus minus. So f prime of x does not exist, only bottom one equal to 0. X squared equal to 0. What is x? X is 0. We have three numbers, so like this. Only positive one is critical number because domain. X is just the positive numbers, right? Only choose positive 10 cubed. So next, so you can draw domain. Domain is from 0 to infinity. Choose critical number 10 cube, the 1000. I can choose test number. So this is like less than 10 cube, I can choose 1. You plug 1 into x. So 1 square minus 1 million is negative. 1 square is positive. We have negative. This is f prime. I'm going to choose this one. What's that? 10 to the 4. You plug 10 to the 4 into x squared. 10 to the 8 minus 10 to the 6 is positive 1. Bottom one is 10 to the 4 is square is also positive. We have positive. What's it like f of x? F of x is decreasing and increasing. What does it mean? We have minimum. So this is exactly only graph is decreasing and increasing exactly absolute minimum at 10 cube. This is a whole idea. So like this. So what's it like y value? You plug the 10 cube into y value. What's it like y value? Do you remember the y value? Y value is here. What's y? This one. 1.5 times 10 to the 6 over x. So x equal to 10 cube. You can plug into y. What's it like y? Y is 1.5 times 10 to the 6 over x. You can plug 10 to the 6 over x is 10 cube. 10 cube is crossed out. Change it 3. So we have y equals 1.5 times 10 cube. This is y. So he minimized the cost of fence when x equals 10 cube feet. Y equals 1.5 10 cube feet. This is like a whole idea for solving this problem. The next example. Find the dimensions of the rectangle of the largest area that can be inscribed in a circle of radius r. What's it like idea? So you can draw diagram. The diagram is like this. So we have the circle of radius r here, circle with radius r. You can only draw rectangle. This rectangle is inscribed in a circle. The rectangle is inscribed in a circle. So this is like exactly center. This is like R. You can use the notation. This length is X. So this length is like Y. You can use X and Y like this. So it's right here. So this length is X. This is like Y from the center. What's like area of rectangle is A. So what's like A? This whole A is like this. What is length? What's length? So what's the length? What's the length of this one? The length is the y times r. No, this is like, let me see. This length is x. This is also x. Exactly x plus x. We have 2x. What's like width? What's width? Yes, same. Y plus y. Y plus y is 2y. So what's the area? The 2x times 2y. We have 4xy. So like this. So we have it. Step 5. You have to express a to the function of one variable. you can define the relation of x and y. What's the relation of x and y? We can use Pythagorean theorem here. This is x, this is y, this is r. Exactly. X squared plus y squared equals r squared. Subtract x squared. The y squared equals the r squared minus x squared. You plug this one, but not yet. Take a square root. So y equals the square root of r squared minus x squared. So you don't need a negative sign because length is always positive. You plug this y value into here. What's like a? A is 4x times square root of r squared minus x squared. So this is function of x. So one more. What is range of x? Here, x is this length. This length is always less than r. R is radius, always less than r. Also, x is positive number. This is like exact domain. So we have it like this. We have it. The next step 6. Use the first derivative test for finding absolute maximum. So you can take derivative 4x times the square root of r squared minus x squared prime. You have to use product rule. The 4x prime times the second one, the square root of r squared minus x squared plus. First one, 4x times the square root of r squared minus x squared prime. So what is 4x prime? Do you know what's 4x prime? So 4x prime is just what's 4x prime? Yep, this is a 4. What is this one prime? You can calculate like this. R squared minus x squared to the power 1/2 prime. So like this, we can use chain rule. Top 1/2 is down, r squared minus x squared, 1/2 minus 1 is negative 1/2 times inner function r squared minus x squared prime. So this is same to 1/2. I can change the negative exponent to the positive exponent, the 1/. So we have r squared minus x squared to the power 1/2 times. What is r squared minus x squared prime? What's that? What is r squared minus x squared prime? So what do you think? What is here? R squared minus x squared prime. Really be careful. What is a variable? X is a variable. What's R? R is fixed number, constant. The R squared is constant. Constant prime is 0. Oh, sorry, prime. The minus x squared prime is negative 2x. Exactly, negative 2x. Really be careful. Not even 2r, is right? R is a constant, x is a variable. X is a variable, exactly, negative 2x. Okay, so this one. The 2 is crossed out. So we have this one. Negative x times 1 is minus x over. So square root of r squared minus x squared. This is exactly this one. So we have this result. So like this. Let's simplify. So we have it. So next, combine. So this is exactly same to the 4 times square root of r squared minus x squared over 1. You can make common denominator, so multiply top and bottom by square root of r square minus x square. So what's that? Same 2, you can keep 4. Here, the square root is gone. So we have this one, the minus 4x squared over common denominator square root of r square minus x square. So distribute 4. We have the 4r square minus 4x square minus 4x squared is 8x square over square root of r square minus x square. So we have it so like this, and factor of 4. So 4 times r square minus 2x square over the square root of r square minus x square. So we have it. So next tip, you can find critical number. So either f prime of x, a prime of x equal to 0, what does not exist. So what is a prime of x? So here, a prime of x is the 4 times the r squared minus 2x squared over square root of the 4 minus r squared minus x squared. So a prime of x equal to 0 is numerator equal to 0. Exactly the r squared minus 2x squared equal to 0. You can add it 2x squared from both sides. We have 2x squared equals r squared divided by 2. X squared equals r squared over 2. Take square root. X is the plus minus square root of r squared over 2. So what's like x? Plus minus the square root of r squared is r over the square root of 2. A prime of x does not exist exactly this one. Exactly inside one. R squared minus x squared equal to 0. So we have x squared equal r squared. So take square root, x is plus minus r. We have these 4 numbers. Which one is critical number? Here, what's the domain? 0 to r. So what does it mean? We have 4 numbers. The positive r over root 2, negative r over square root of 2, positive r and negative r. The first one, always 0 to r. So we don't have negative 1. The r is not in the domain. We have only one critical number, r over square root of 2. So like this. So next, you can check. Do we have maximum or minimum? This one. Domain is here, 0 to r. The critical number is r over square root of 2. You can plug the test number into a prime of x. A prime of x is the r squared minus 2x squared over the square root of r squared minus x squared. This square root is always positive, so this is always positive. Only check numerator. But here, so what's that? I can choose number is very close to 0. We can choose a test number very close to 0, this number. So you can plug here. What happens? So this number is very close to 0. The r squared minus very close to 0. So what happens? This is a positive. So this is a prime of x is positive. So you can choose a number very close to r. You can choose very close to the r, plug into here, very close to the 2r square. The r square minus 2r square is negative r square, like negative number. So what's like a of x? A of x is increasing and decreasing. What does it mean? We have absolute maximum at r of root 2. Is right? R of root 2. So we have the like this. How can you find the y? So we can use relation of x and y here, the next one. How can you find the y value? The y value is exactly square root of r square minus x square. You plug this value into x. So we have square root of, yes, r square minus r over square root of 2 squared. So we have the square root of r squared minus the r of square root of 2 squared is r squared over 2. You can simplify. This is square root of r squared over 2. The square root of r squared is r. Bottom one is square root of 2. The y is also r over root 2. So we have. So what is the answer? The dimensions are the 2x and 2y's, right? Remember, the previous one is we have circle is like one, you can find rectangle. Was like length is 2x. Width is 2y. So we have dimension is 2x and 2y. Was like 2x. The 2x is exactly the 2 times r over square root of 2. You can only rationalize denominator. So like this, same 2 times the r times root 2 over 2. 2 is crossed out. Answer is the square root of 2 times r. Was like 2y, same. The 2 times r over square root of 2. You can times root of root 2, the same. So we have the 2 times r root 2 over 2. 2 is crossed out. Answer is root 2 over times r. So we have these dimensions. Okay, so this is like all for today lecture. Thank you for attending my live session. I appreciate you. And then if you have any question, could you write your question on the chatting board? So if you don't have any question, you can leave this live session. Okay, thank you very much. You're welcome.